Hello and welcome to another PHS1011 video as usual. I'm Kevin Pimblett and joining me is Tim Peterson. Hi Tim.
G'day Kevin.
So we noticed a few things on the discussion forum this week. We asked the students what they're looking forward to and quite a number of them said entropy, and there was a couple of people who said special relativity and a number of other things. There was also a really decent thread on people helping each other solve some problems through physics.
Yes, we're really happy to see that.
Absolutely. So what would you like to talk about today, Tim?
Well, special relativity and entropy, they're quite exotic concepts, but they're actually based on very simple founding principles and phenomena in the real world. For example, one person that Einstein revered and used to formulate his special relativity was Galileo.
And I heard Galileo did an experiment with the Leaning Tower of Pisa.
Yes, Galileo was, like Einstein, a person who tried to simplify his theories about nature as much as possible, and he was studying linear motion.
I can't help but notice you've stolen some of your daughter's toys.
Yeah, so the Leaning Tower of Pisa experiment involves dropping two weights of unequal masses from an identical height and seeing how long they take to reach the ground.
Okay, so I presume we're going to do a similar experiment with your stolen daughter's toys?
Yeah, these were hand-picked by my trusty 3.5-year-old assistant, and we've got the princesses here in an evacuated ball, which has a low density, and we've got the glitter ball here, which is full of fluid.
So quite a different density.
Yeah, it's quite a bit heavier.
So what's the experiment we're going to do, Tim?
Well, I just did the experiment there. It was a little quick. We need to drop these balls from a larger height.
A big height.
Yes, and being similar in size and shape, geometrically equivalent, the friction on these balls should be about the same.
Okay,
and
what do we want to test?
Well, we just want to see how long each ball takes to reach the ground from the height of, say, the stairwell.
And are they going to be the same or different, do you think?
Well,
I guess we'll find out.
We should wait and find out if we're going to be real experimentalists.
Okay, sure. Let's go and find a great height to drop them from.
So motion in 4 dimensions, that is 3 spatial dimensions and time, can be quite complicated, like this ball here that I'm moving around. When we do experiments in physics, we try to simplify them as much as possible. And with motion like this, one simplification we could make is to just study the motion along a line, so linear motion.
So this is a bit like the Leaning Tower of Pisa experiment, except we've got a nice big stairwell to throw the balls down today.
Yeah, so what we're going to do is we're going to have a race, and you take that ball.
Thanks.
I'll take this one. We're going to drop these at the same time, and we're going to see which one lands on the ground first.
Okay, better put them at the same height.
Yes. Okay. My money's on the princesses.
Okay. Do you want to give me a countdown, Tim?
Yeah, so we'll go backwards from 3 on 1. Ready? 3, 2, 1.
So, Tim, the outcome of the experiment there was that the balls hit the ground at roughly the same time, give or take a little bit of human error.
Yeah, I was kind of hoping the princesses would win, but I guess I was wrong.
Okay, so why do they fall at the same rate?
Well, from a modern perspective, we know that objects of unequal masses fall at the same rate. So the time that they take to fall determines the distance that they fall, and the converse is true, and not the mass and not the colour or any other attribute.
So how did people react in the time of Galileo to this?
Yeah, so back in the Renaissance, people were genuinely surprised. I think it contradicted some philosophy of Aristotle, or one of those Greek philosophers. Of course, we're not surprised anymore, and you learn this thing in school. But the point of the experiment was to show that how simple such an experiment is, and how simple the outcome was. Simple outcomes are great because they act as guiding principles for theories of physics. And so Galileo didn't just do vertical motion, he also did experiments on horizontal motion, looking at conservation of kinetic energy. And out of all of that, he in fact formulated the principle of relativity.
Not Einstein's relativity, though.
No, Galilean relativity.
Galilean relativity. And, you know, this comes back to something that we've been looking at in class a little bit over the past few weeks. We've been having a look at the system and defining that quite precisely over the course of investigating a number of problems, and this ties into the discussion forum threads we spoke of earlier with relativity.
Yes.
And that's it from Tim and I for this week, and we look forward to seeing you on the next video and indeed inside class. Thank you. Good evening.
Thank you.